All right, everybody, here we go. Section 2.2, Rational Equations. So I wanted to convince you of a couple things, first of all, before we actually start doing problems. First of all, if you look at this equation that we have right here, this first equation, you have x times x minus 5 equals 2 times x minus 5. I just want to note right off the bat that there are two different numbers that you can just look at it and kind of see that there's a solution without even solving. If you plug in 2 for x, if you substitute the value of 2, you get 2 times 2 minus 5 equals 2 times 2 minus 5. We can see that's going to be the same thing. So 2 is a solution. 5 is also a solution because if you substitute 5 in for x, you get 5 times what turns out to be 0 equals 2 times 0, and that also is true. So just at the outset, without even doing any real algebraic steps, you can see that there are two solutions, 2 and 5. And anything that we do afterwards has got to yield the same two solutions, 2 and 5. Because this equation is equivalent to the ones that you might have below, you've got at every step you've got to have these two solutions. So one thing I'm going to do to both sides, I'm going to divide both sides by x minus 5. I mean, you can divide both sides by a number like 3. You can divide both sides by a number like 6 or 10 or negative 1. Why don't we just divide both sides by x minus 5 and see what happens? So this is kind of the key step that I'm going to want to come back to. But you can do this. You can divide both sides by x minus 5, and in order to do that, you can cancel. Cancel, everything cancels. Notice I'm not canceling just the x or just the 5. I'm canceling the entire factor because it's x times. There's multiplication right here and multiplication right here. So when you do that, actually most of it cancels out. You're just left with x equals 2. But wait a second. We knew that 2 was going to be a solution, but 5 should also be a solution. Somehow in these steps we dropped there are two solutions to this equation, and there's only one solution to this equation. We dropped one of the solutions. What happens? At the very bottom, we should also have x equals 5. Well, one thing I wanted to teach you is that when dividing both sides by an expression, also set the expression equal to 0 and solve. So I divided both sides by x minus 5. You're allowed to do that, but whenever you do that, you also have to do some side work and say that expression that I divided by both sides, x minus 5, well, that x minus 5 could also equal 0. And that could also produce an additional solution that normal algebra over here won't produce. So here, this is where the x minus 5 comes in. And now once we take this into account, we can see that we get both solutions that we predicted at the very beginning, 2 and 5. The next kind of cautionary thing I wanted to show is if this was dividing both sides by an expression, here's multiplying both sides by an expression. So let's start with something like x equals 1. And basically, like whatever we do, we've got to make sure that the resulting, every equation at every step has got to also just equal x equal 1. And so I'm going to multiply both sides by an expression like x minus 2. And this is kind of the key step I'm going to come back to eventually. But when you do that, you can FOIL it out. You get x squared minus 2x equals, distribute this. Sorry, not FOIL. You're going to be distributing both of these sides. X squared minus 2x equals x minus 2. Subtracting x minus 2 from both sides, you get x squared minus 3x plus 2. Factoring, you get this. And solving the factored form, you get this. But wait a second. We started with x equals 1, and there's only one solution to that. It is the solution with 1 right here. X equals 1. Where did the x minus 2 come from? Well, it came from the fact that when multiplying both sides by an expression, you've got to check your solutions. There could be extra solutions in there. So here you can see x equals 1. If you check both of these in the original, check this in the original, you can see 2 doesn't equal 1, so this kind of extraneous solution needs to get crossed out. So those are the two big ideas, the two major new steps, or two new ideas that I wanted to talk about. What happens when you divide both sides by an expression, and what happens when you multiply both sides by an expression. So now I want to show you just a couple of strategies that you can use when you're solving equations. First of all, clear the fraction. So if you have x over 2 plus 3 over 2 equals 6, you can multiply both sides by 2 in this case to clear the fraction. This is a little tricky to solve, but this is way easier. And that's because there are no fractions. So whenever you see fractions that you can completely clear, it's a good step to do. So that's the first strategy. Second strategy is, at the outset, note the non-meaningful replacements. So what I mean by that is here, in this equation, just as kind of maybe as a first step, or as soon as you see it, just note that, wait a minute, if we ever get x equal to -5, then that should not be a solution, because I'm checking, like, let's say we do a whole bunch of algebra, and then at the end we get, bing, x equals -5 as your answer, or one of your answers. You have to cross that out and say, no, x can't equal -5, because if you put it in the original, you get numerators, stuff in the numerators, and you get 0 in the denominator, and you just can't have 0 in the denominator. So whatever we do, we have to make sure that we don't let x equal -5 as a solution. All right, so that's note non-meaningful replacements right here. Let's clear the fraction. Let's take the first strategy. So I'm going to multiply both sides by x plus 5. But wait a minute. When multiplying both sides by an expression, you have to check your solutions, because there could be extras. So I'm going to multiply both sides by x minus 5, and you get, and it clears the fraction. So we get x plus 4 equals -1, and therefore x equals -5. But if we check it in the original, like we did already for -5, we can see that x should not equal -5. You'll get a 0 in the denominator. So there are no solutions to this equation right here. We thought that we might get a solution of -5, but when we checked it in the original, we could see that x should not equal -5. All right, next. The next strategy is finding the least common denominator. You remember, you've done this before with fractions. You have 1/2 minus 1/5. And so you can multiply both the top, the numerator, and the denominator by 5 to get 5/10. What's the motivation for doing that? It's because we've seen that the least common denominator is got to be 10. The 2 times 5 is 10, and there are no lesser common denominators than that. It's the least common denominator. So multiply this by 5, and multiply this fraction by 2 to get the least common denominator of 10. So you get 2/10, 5/10 minus 2/10. Now that's something you can do, because 5 minus 2 is 3/10. We're going to do a very similar structure here, except algebraically. So if we're given this, you can copy it down, but I think a good thing to do at the outset is just to remember that whatever we do below, we have to make sure that x doesn't equal -2 here or +4 here. These cannot be solutions. And if we think they are, we've got to cross them out because they will create zeros in the denominator. All right, so that's note non-meaningful replacements. Let's find a least common denominator. Just like here, 2 times 5 is 10, and there's nothing lesser than x plus 2 times x minus 4 is going to be our least common denominator. And you can see it here. X plus 2, x minus 4, x plus 2, x minus 4. That's the least common denominator. It's an ugly one. It's extremely algebraic. It's different from what we're used to, but it is the least common denominator. And what do you have to do to multiply this fraction to get your least common denominator? You have to multiply it by the expression that's missing from it. It already has an x plus 2. You need to multiply it by x minus 4 in the denominator and in the numerator to make sure it doesn't change anything. So we're multiplying this by a form of 1, this little fraction over here. This does not automatically activate this because it's multiplying. We're not multiplying both sides of an equation. We are simply multiplying this, where is it? We're simply multiplying this one fraction by a form of 1 here. And then here we are multiplying this for the same reason. To get the least common denominator, you have to multiply by the missing expression. We already have an x minus 4. We need to multiply it by an x plus 2 in both the denominator and the numerator. So there it is. And now that we have common denominators, we can do the subtraction. We can turn it into one fraction here. 14 times x minus 4 minus x plus 2. I really think it's important to remember these parentheses right here, because if you don't, you might just accidentally write all this minus x plus 2. And really, you have to make sure you're subtracting the entire denominator. The entire numerator. Subtract this entire numerator minus this entire numerator here, and eventually we'll get rid of these parentheses and we'll realize that this should be x minus 2. So remember these parentheses, they help you subtract the entire numerator. Okay, so we've gotten here, and now that we have just one fraction, we can clear the fraction easily. And we'll do that by multiplying both sides of the expression by this denominator. But now that we activate this idea of when multiplying both sides by an expression, you have to check your solutions. So we just have to be really careful that that at this point we realize, yes, we are required to check our solutions. When we multiply both sides by that denominator, you get this. You can see we still have the numerator, but the denominator gets moved over here because, it cancels on this side, and 1 times the denominator is the denominator. I'm going to show the rest of it and just narrate it as we go. So this is the old numerator, and this is the old denominator over here, times 1 over here. Getting rid of the parentheses, we distribute here. We distribute this subtraction to the x and to the minus 2. Combining like terms, we get 13x minus 58. That's minus 56 minus 2 is minus 58. Then we can subtract 13x from both sides. Foiling, we get this over here. And subtracting 13x from both sides, we get minus 15x. Adding 58 to both sides, we get 50 right here. Factoring, we get x minus 5, x minus 10, and setting both of these equal to 0, we get x equals 5 or x equals 10. Now, we have to make sure we check our solutions in the original because, because there could be extra solutions. So, checking our solutions in the order 5 and 10, we can substitute them in. We get 5 over here. We get 14 over 5 plus 2 is 7. 14 over 7. I really should be writing this down, honestly. Minus 1 over 5 minus 4. So we get 14 over 7, this is 2 minus 1 equals 1. So that checks out. 5 checks out. And 10 will also check out as well. They're not negative 2 and they're not negative 4, and that's good. Okay, so these are the two answers. Okay, last example. We've got 4 over x plus 5 plus 1 over x minus 5 equals 1 over x squared minus 5. And at the outset, we can see, wait a minute, whatever we do, we got to make sure we don't accidentally try and say that negative 5 is a solution and positive 5 is a solution, because if they are, they're actually really going to create zeros in the denominator, and that's just not good. A really good first step would be to try and find a least common denominator. You really can't find a least common denominator unless you factor. So the first step of finding a least common denominator is factoring everything you see. Sometimes, in the more complicated examples, you'll see stuff on the top or stuff on the bottom that you need to factor. And so, just when you see these rational expressions, just start factoring, and then it'll get a lot easier. So we factor this denominator right here, and so we get 1 over x plus 5, x minus 5, and if we hadn't already said, wait a minute, x should not equal negative 5 and x should not equal 5, then I would definitely say it right now also. But this is kind of repeat. Okay, so let's find the least common denominator. From all these fractions, the least common denominator is going to be this one right here, because you can multiply this fraction by x minus 5 to get the least common denominator. You can multiply this fraction, both the top and the bottom, by x plus 5 to get the least common denominator. Now that we have common denominators, we can add the fractions, and we can add the fractions together. You combine the numerators, and notice the denominators stay the same. And then we can clear the fraction. How do you clear the fraction? You clear it by multiplying both sides of the equation by that denominator. Now, this should activate a wait a minute, I'm multiplying both sides by an expression. What that means is that we're going to have to check our solutions. There could be extra solutions that we involve. In general, anytime we clear the fraction, that's when you clear the fraction and the fraction has a algebraic expression, that's multiplication. So you have to worry about creating extraneous solutions. All right, so here we go. We multiply both sides by the denominator. We're going to distribute. I'll show you the rest of it right here. We're going to distribute, combine like terms. We're going to add 15 to both sides and divide both sides by 5. X equals 16 over 5. So checking this solution in the original will be kind of difficult to do, 16 over 5 in here and here, but the important thing, I think, really is that they're not equal to negative 5, and are not equal to 5. So this solution holds, and that's good. That's our one solution. All right, I'd like you to begin assignment 2B. I'd like you to copy the problem list and do the first problem. And, as an audio check, I just want to let you know that Earth happens to be a third planet from the Sun. It's a pretty special place. And I'll see you on Earth tomorrow.